Hello. So in this video, we're going to continue OSPF part 2. And I need to apologize. I have a little bit of a cough going on, so I may be coughing, pausing this the recording, or just trying to get through this as quick as I can. But it's all good. So we're still using the same lab document available on my GitHub repository. We're going to, in this part of the lab, as you can see, we're going to modify the auto cost reference bandwidth. We're going to adjust, what are we going to do? Adjust the hello and dead intervals. We're going to do some point-to-point links. What else we're doing here? Oops. Let's see. Passive interfaces as well. There's some additional information on here in this document as well, including about the DR, BDR, and also what happens when a link goes down and the adjacency and all that kind of good stuff, the LSA process and all that. But I won't go into that here. Here's a cough. Let's go ahead and get started. Okay, I'm going to move this off to the side. So we're going to begin by modifying the Now, why are we doing this? Modifying the reference cost bandwidth. Let me go to the core router. I'm going to do a show IP route OSPF. And we can see all of our networks here. That's learned via OSPF. And right now, every link has a cost of 1. I talk about this in my OSPF presentation, so I won't go into it here. But this works fine for here only because all of our links are gigabit links. But if we had links that were fast Ethernet, gigabit, 10 gigabit, then because of the default auto reference cost bandwidth uses 10 to the 8th or 100 million. So anything 100 megabits or more will have the same cost. So we're going to see how we can modify this. So if we do have links that vary from 100 megabits up and even below, but 100 megabits, gigabit, 10 gigabits and more, then they will receive a different cost. Right now, everything 100 megabit and more is getting a cost of 1. Matter of fact, we can see this here, show IP type. Okay, we can see it has a cost of 1, although this is a gigabit link. So let's go ahead and let me show you. It's a very simple command that we're going to use. We're going to actually modify it on all routers. So I'm going to start here with doing it on core 1. I'm just going to copy and paste my configuration. Oh, but there we go. That's all right. So I just show you, I have a script that I use. And if these commands are already enabled, it just ignores it. So anyway, here's the command here. Go into the OSPF process, auto cost reference bandwidth, and we're using 10,000. So that 10,000 is actually, that 10,000 is actually in megabits. So basically what this is going to do is make it so everything is 10 gigabit is our reference bandwidth, 10 billion. So it will give us different values for fast Ethernet, gigabit, and 10 gigabit. 10 gigabit will get a cost of 1. So as you can see here, it says reference bandwidth change, please ensure it is consistent across all routers. So what I'm going to be doing next here, and I'm just going to show it to you on 1, and then I will pause the recording so you don't have to watch me do it on every router. So I'm just going to go to each router, including Edge here, do a paste. And you can see I'm actually issuing the same command on all of our OSPF routers. So we don't have any inconsistencies in our shortest path firsts. Okay, so I'm going to pause the recording here and do that on all the routers. When I mean all the routers, Edge, DC1, Core, all 4 core routers, all 4 distribution routers. Okay, now that I've done that, let's go back to our core one router. And before we did show IP OSPF interface gig 103, we saw it had a cost of 1. And we also saw that all of our metrics in our routing table, cost of 1 for each of the links. So it almost looks like hop count in a way, but it's not. Okay, so let's take a look here. Let's do, and I'm going to do show IP route OSPF. Okay, so you can see now they've all actually same path. So none of that has changed. But you can see that they've all been increased by a factor of 10. Okay. Let's take a look at one of the interfaces. Oh, that's not what I want to do. Oh, yeah, it was. That was the command. Show IP OSPF interface gig 103. And notice now our cost instead of 1 is a cost of 10. All right, so that worked pretty well. Next, let's go ahead and we're going to take a look at modifying the the hello and dead interval values. Okay, so let's go, well, we're on core one, let's stick here. So, and us actually looking at show IP OSPF gig 103 will work. So we can see right here, it offers us some good information here, the hello and dead intervals. The hello interval is 10 and the dead interval is 40, this is the default for Cisco for all broadcast interfaces, what we mean by Ethernet. And let's go ahead and take a look at what happens when we're going to modify this. But let me mention a couple of things. We're looking at core right here. This is on a per interface basis. And to form an adjacency with another router, like core 2 here, the hello and dead intervals must be the same on both interfaces, both of their adjacent interfaces. Now, they can be different on other interfaces as long as they are the same with their adjacent neighbors. Okay, so let's go ahead and change this. Now, why would you want to change it? Okay, as we'll see, when we modify the hello interval, hello means it's going to send hello every 10 seconds. If I don't hear from the router in 40 seconds, I'm going to declare that neighbor as dead down. I'm going to remove its LSAs. I'm going to rerun the SPF algorithm if necessary, which it will, and it will recalculate the route. So it will also let other adjacent routers know that this router here is no longer a neighbor of mine. That can take a little time and maybe 10 seconds, especially in data centers. But anyway, this is a whole nother topic. We may want to decrease that a little bit. Let's see if how we can decrease it here. Okay, so what I'm going to do, excuse me. Okay, I'm going to go into that interface. This is my adjacent interface with core 2. Interface gigabit 103. And I'm going to change the hello interval. And I'm actually just going to copy this in here. Copy and paste it here. And I'm also going to change the dead interval. So I'm going to change the hello interval to 5, the dead interval to 20. Now, Cisco iOS will automatically modify the dead interval to 4 times the hello interval unless you make it different. I always, believe that you need to never rely on defaults. You want it 4 times the hello interval? Type it in. So let's go ahead and do that. Okay. There we go. Modified them both. Now I'm going to go over to core 2 here, and we're going to take a look at something. Show IP OSPF neighbor. Okay, let me make that a little bigger here. Here's our neighbor. Okay, it just looks 25 seconds. Okay, so the dead interval is 40. You can see that it's already increased. This should really never fall below 30 seconds. Okay, so but you can see it is because it is not getting a hello. 3 seconds, here we go. Can we get 1 second? 0 seconds. Oh, there we go. Perfect timing. Okay, so core 2 just says, sorry, I've been maybe receiving hellos, but we're no longer adjacent neighbors because your hello interval and dead interval are different than mine. So I wasn't accepting your hellos, and now you're no longer a neighbor of mine. Matter of fact, show OSPF neighbor, you're gone. Okay, that was core 1 right there. Okay, remember we're on core 2. Okay, so matter of fact, if we go, the cool thing, go over to core 2, we see the same message. Okay, we're going to see that it says here on core 1, by the way, OSPF adjacency change. Okay, that's our OSPF process. Neighbor, that's our, we're on core 1 here. Neighbor quad 2. What did I change over? Let me go over here. This is the one that we're doing the dead intervals. Okay, the show IP OSPF neighbor. We'll come back to the core 1. Excuse me for that. Okay, core 2. Okay, as I was doing that show OSPF neighbor command. Okay, right. There's our OSPF adjacency change, OSPF process. Our neighbor quad 1. It says you're no longer a neighbor of mine on that. My interface went full of down. That's because the dead timer expired. Okay. And it's just letting me know that neighbor's down. Maybe the interface is down or detached. Something happened. And anyway, I removed you as a neighbor. And like I was showing you also, here we go. We see the same message on core 1. All right. All we need to do now is modify this on core 2. Okay, so in core 1, we modified the hello and dead intervals, right? So let's do the same on the adjacent interface with core 2. So let's go ahead and do that. Okay. Now we should see another OSPF adjacency change. This time should be good news. Yes. Okay, yeah, good news. Loading to full, loading done. That's what we want to see. We should see the same thing on core 1. Yes, it came back. It says, there you are, you're back. Core 2, neighbor, your OSPF router ID there. Okay, loading full. Okay, matter of fact, if we do show IP OSPF neighbor, we should see that. We should see each one as a neighbor. Can I spell this? No, I can't. There we go. All right. Core 2 says, I see you. You're back, core 1. Okay. All right. So that's just how you can change the hello and dead intervals. Again, only has to be the same with the adjacent neighbor. The next thing I'm going to want to show you is point-to-point links. We're using Ethernet as our point-to-point links, which is by far the most common nowadays. There was a time that we used to use serial point-to-point protocols like PPP, HDLC, even things like frame relay, ATM, and others. But now everything is pretty much Ethernet, especially in the enterprise world. So let's take a look. Let's go to Edge here. So I have the right, there we go. Let me take a look at Edge. Give me 1 second. Okay, so we're going to see here at Edge, it has an interface with Core 1, point-to-point link, no other routers or OSPF routers on this link. It's just a point-to-point link. So let's look at Edge here. I do end. Okay, I'm going to do my show IP OSPF. I'm going to take a look at that information on that link there. Show IP OSPF interface gig 1. That's this link right here. And you can see that what it's showing us is that it is of type broadcast. Okay. What that means is that it is electing a designated router, which is this router, and that's its own router ID. And there's a backup designated router on the link, which is Core 1. Well, we're the only two on here. And in my lab, I talk a lot about DR and BDR and the need for it and that. But there's absolutely no need for DR and BDR when there's only two routers on the link. Okay. It's like having to elect, well, I don't know, if you've only two people in a club announcing somebody as the president, somebody the vice president, and it just doesn't make sense. Okay, there's only the two of us. All right. So the command I'm going to give here is on this link, is this command here. And I'm actually going to follow the copy run to start so I can save what I'm doing here. Okay, so the command on this interface, I'm going into that specific interface. This is gig01, IP OSPF network point to point. And I'm actually going to pause the recording here because I'm going to do this on all the interfaces. Matter of fact, I'll show you. I'll do it at least on Core 1. So you get an idea that I'm actually doing this on all the interfaces. So here we're at Core 1. And I'm following this with copy run to start so I can save all this. So let's do it. So on Core 1, I'm going to give the same command on 1, 2, 3, 4, 5 interfaces. Okay. Let's see that. Again, I just use my nice little text document here. Copy and paste whatever I want in. Okay, wow, a lot of changes in adjacencies, okay? But you can see these are the commands. Same command on every interface, okay, where there's just another router, okay? For DC1, okay, I won't be giving that command. It's not a point-to-point link, okay? So on DC1, by the way, okay, the only place that I'll be giving that command, I'll show that here in a moment, is on this link here. Okay, so it will have a point-to-point link, but not for this one here. Okay, so let me pause the recording here. Okay, I'm going to show you my text document here a little bit more so you can see I did it on all. I'll quickly show you some of the other ones as well. But here's my text document. So you can see it just makes it really easy. Make sure I've got all the interfaces. Here's Core 1. Distribution 1 was just this interface here, not this one here. We're going to do something else here in a moment. But Core 2, Core 3, Core 4, Distribution 1, Distribution 2, Distribution 3, Distribution 4. Okay, so a lot of links here we took care of. You can see some of them I use the interface range command to do two links at once. Okay, next we're going to do passive interfaces, as you can see right here. Oh, I know. Let's first, before we get there though, we need to verify what we just did. That would be nice. Okay, so let's take a look at that. Let's go to Core 1 here, and let's do a show IP OSPF interface. What was this here? What link was this here? Gig 1023. And you can see that all the links will change from broadcast to point to point. It's for the network. That's the network type. Go to Edge, see that changed also. So I have there we go. This is this link here with Core 1. Okay. And it is important that your adjacencies have the same network type. Yep. All right. We're almost done here. Now what we're going to do is configure passive interfaces. What is a passive interface? Well, look at DC1 here, Distribution 1, Distribution 2. They have connections that there are no other routers out here. Meanwhile, every 10 seconds, they're sending an OSPF hello because we have those interfaces enabled, configured as part of the OSPF process, which is important. Don't not do that because that if you remove, like say the network command, distribution one, remove this network command, it will no longer advertise that LSA. In other words, won't advertise this network to other routers. So these routers won't be able to reach it. Okay, but what we can do is, let's go to distribution one here. Okay. And I'm going to do a show IP OSPF interface gigabit 101 here. Okay. So we kept it as a broadcast. Okay. And is there anything else? Let's see. But we don't have any adjacent neighbors. Neighbor count is 0. Adjacent neighbor count is 0. We don't have any adjacent neighbors out here. Okay. But it's still sending hellos out that interface. Okay. So what we're going to do here is simple command. Is we are going to say, go into router OSPF1, and we're going to actually say on both of these interfaces here, since we have no router, we're going to make them passive, meaning just do not send out hellos out those two interfaces. Now we want to continue to send out hellos out these interfaces because we do have adjacent neighbors. Okay. And once I've done that, let's go back to show this command here, show IP OSPF interface gig 101. We can see that it says no hellos, passive interface. All right, so what I'm going to do is give this same command on DC1 on this interface, distribution 2 on this interface. And for those doing my lab, yes, distribution 3 and distribution 4, you would do that on these two interfaces of each, but I've already done that for you. Okay. So well, let's go ahead and just do distribution 2. Too many to do here. Here's distribution 2. Paste. There's its two interfaces. And let's go to DC1 here. And I always like to save the running to start in my lab. And also, don't forget to do this, right? Save every so often. Yeah, Rick gets paranoid with these things. Okay, let's take a look at show IP protocols. See what that tells us about that. Okay, as you can see here, okay, it actually tells us which networks it's routing for. So it says, yes, I'm routing for this network and this network. That hasn't changed. But I do have a passive interface in my gig 101. I'm not sending hellos. Okay, so I won't be establishing any neighbors on that interface because we don't have any OSPF routers. All right, last few final verification commands. Let's go here to distribution 1. That's way down here in the corner. Let's make this a little bigger here. I'm going to do show IP OSPF out of the way. Neighbor, you spell neighbor, do it that way. All right, so I can see I have my 3 neighbors. That's what I expect. Core 3, core 4, distribution 2, looks good. Okay, whenever you're verifying, you should know what you expect to see, and if there's something that is there that shouldn't be there, you should recognize that as well. Let's do show IP route. OSPF, just look at our OSPF routes. Again, notice the factor of 10. Okay, so it looks like I can see just about I can see all my internal networks, and there's that default route that we had from the previous part 1 lab. Okay, show IP protocols. It's a good one to look at. Okay, this is our routing protocol we're running, process ID. There's our router ID. These are the networks it is routing for. Okay, that was due to our network commands, OSPF network commands. We have two passive interfaces. These are all the router IDs of the routers in our area, and this is the OSPF administrative distance. And let's just take a look at this as well. One of the interfaces, this is our interface that is gigabit 1024 with distribution 2. So just taking a look at some of the information here. So we have this is this adjacency here. Okay, we can see our all that good information, point-to-point link, cost of 10, state point-to-point, hello and dead intervals, all kinds of good times. But next, hello do. Adjacent with neighbor, that's the distribution 2. There we go. It's OSPF router ID. Okay, the final test. You can see this is left over from previous lab here, but let's take a look here. Okay, IP config. It all starts here, by the way, right? Make sure you have all your IP addressing configuration correct, whether it's statically or correctly getting it from OSPF or DHCP. There's OSPF on the mind here. Okay, there's this IP address, subnet mask, and got to have the default gateway, distribution 1 in this case. Okay, let's see if we can ping this server here, 11110 from PC 0. Don't be surprised if you get a few timeouts. You might even have to, with packet tracer, you might actually have to do this command 2 or 3 times, because if you have not been, if you just brought up the network or just configured it or just brought up your packet tracer file, there's all the ARP tables in all these devices are empty. So everything has to do an ARP request, get an ARP reply for the neighbor's MAC address, for the next hop IP address. So you might have to do this more than once. Okay, let's do a trace route. And this is great, right? So we can see it going through distribution 1. Okay. Then it looks like it's going to 200, 100.5, core 3. And then now you might the trace, I'll have to explain this in a different video here. But there is you'll see here it's actually getting why is it getting the saying 17 here out this interface when it most likely went up here. It just depends on how the core 1 is sending back the time exceeded message. I'll talk about this in my class, but anyway, you can see it goes here and then to edge and then to ISP and then to this other ISPs and then finally to here. Okay, but it's just getting back to this real quick. It's just how it wants to send back the ICMP time exceeded message. It's actually the way that core 1 can get to this network here has a couple of paths. It can go via core 3 or it can go via core 4 and this way. So although the packet is going this way, the time exceeded message, the initial packet's going this way, the time exceeded message, well, I got core 1 says I have 2 ways to get there. I don't have to send it back this way. I can send it back this way. Okay. So that's why sometimes you do not see the trace route being exactly what you would expect going. It's not typically doesn't have to be the ingress interface of core 1 to what it received the initial packet on. It's the packet it's the interface that it's sending the ICMP time exceeded message on. All right, well, that completes our OSPF lab. I hope you found this helpful. Again, I have this huge document here for my students. So you're welcome. Everybody's welcome to access this and use it. I hope you found this helpful. Thank you very much. Have a great day.